Hey everyone, and welcome back to the lecture 4 of our learning series where we are learning machine learning and AI. And starting for today, we'll first look into the fun fact as we have promised. So today's fun fact is Earth. Earth's rotation is changing speed, and actually it's slowing. This means that on average, the length of a day increases by around 1.8 seconds per century. 600 million years ago, a day lasted just 21 hours. So you can see that this fun fact is really amazing because I was also not knowing this. Let's move to the today's topic. We were doing the linear regression and where we saw the definition of it and also the main rule that was it assumes that there is a linear relationship. Okay. Then we read about what is independent variable, what is dependent variable, and we saw the example too. Containing the same, we'll do is goal of linear regression. Okay. So what is the main goal of linear regression? So the goal, I hope you're making notes, write with me. The goal of linear regression is to find a straight line that minimizes the difference between the observed data points and the predicted values. Okay. So the main goal of linear regression is to find a straight line. That means it will be in form of graph. It may be a straight line. Okay. So that minimizes the difference between the observed data. That means the data we have and the points predicted. Okay. So prediction we are making. The straight the line is the accurate the regression model it is. Okay. Now let's see the equation of linear regression. Okay. So let's see the equation of linear regression. So it is in form of, so now let's see the equations of linear regression. So we have one main equation that is y is equal to mx plus b, where y is the predicted value. Okay. That is our dependent variable. So it will be our dv. Okay. Next, m is the slope of line. That is also equal to change in y when x changes. Okay. This is important. Next, x is our independent variable. That is input. Okay. And b is the intercept. That means the value of y when x is equal to 0. So this is the main overall formula for linear regression. Okay. So I hope you understood. Fine. Now let's move forward and we will see cost functions in linear regression. Okay. So Linear regression is a method used to make accurate predictions, may not marked the actual data. So, as I said, that linear regression is main goal is to find that straight line that minimizes the difference between the observed data and the predicted data. Okay, so here they are talking the same. It says LR is a method used to make the accurate predictions. Okay, so our main focus to get that straight line is to get the our actual data and predicted data on the same line. Okay, so here also it does the same work. We want our predictions to be accurate. Okay, why so? If someone say why so, so you should know down to address this cost function is used to measure how far off these predictions are. Okay, so this is all about linear regression and its cost functions. Moving forward, we look into the gradient descent in linear regression. It is a fundamental optimization algos used in linear regression to minimize the cost functions and find the best fit line for the data. Okay, so what is now the gradient desert linear regression? So it is a fundamental optimization algos used to used in linear regression to minimize the cost functions and find the best fit line for the data. Okay, moving forward to the next topic. Now here the linear regression ends. So overall we have saw what is linear regression. Okay, what are its assumptions, what are independent variable, what are its dependent variable. Then we saw the equation for linear regression. Then we saw the cost functions and its reason, and then gradient descent in linear regression. Now here this topic ends, and now we'll be starting through multiple linear regression. Okay, so now let's start with multiple linear regression. Okay, so if I say it is so multiple regression is same as linear regression, but basically the difference is it deals between a dependent variable that is affected by more than one factors. So basically multiple linear regression deals between a dependent variable that is affected by more than one factor. If we look the basic difference between the equations of both of them, so linear and linear regression. Okay. So if I say it is, so multiple regression is same as linear regression, but basically the difference is it deals between a dependent variable that is affected by more than one factors. So basically multiple linear regression deals between a dependent variable that is affected by more than one factor. If we look the basic difference between the equations of both of them, so linear and multiple linear. So the equations are like y is equal to BO, that is multiplication sign, okay, into x1. So this will come the overall for linear one, and the multiple regression equation is like y is equal to I'll write it again, and the multiple linear equation is like y is equal to BO plus B1 multiplied by x1 plus B2 multiplied by x2, and it will continue till Bn, that means infinite numbers into xn. So this is the main difference between both the formulas, okay, of linear and multiple linear equations. Okay, so if you look closely till this, it's same, but it deals with multiple independent variables. So here comes the main difference between both of them. Fine. Moving forward, now I will give you the hands-on main formula which you can use and the steps which you can use to find its linear regressions and multiple regressions on head-ons. Okay, not through calculators, not through system, but how can you calculate on with your hands. Okay, so that's all for this video. I hope you understood some basics about linear regression and its type, and so that's all for this video. I hope you understood some basics about linear regression and its type, and also a small introduction to multiple linear regression and its formula. And I hope to see you in the next video. Thank you so much.